Alright, welcome back to the 2015 version of the drive-thru. Hope everyone's having a good summer. It is not over yet, but school has begun. We've done this problem here on the first day of class, and we're introducing you guys to the drive-thru, where we handle all confessionals. The locker problem is just a classic, simple yet difficult and challenging math problem that involves the problem that you can see in front of you. So I encourage you, if you haven't read this problem in class, that you should pause it at this point and read the situation. This is a chance for us to practice some problem-solving strategies. That's going to be the key in math, and that's what we're really trying to teach you about, is how to solve problems. You may not use math when you're 40 years old, but I guarantee you will have problems. I can promise you that. So we're going to write down an organized list, and we are going to solve a simpler problem. So I'm going to write that down. We're going to make a list, and ours is going to be organized because good lists are that way. And we are going to solve a simpler, this isn't an English class, problem. I'm not sure if that is a word. Okay, so we've got 1,000 students and 1,000 lockers in this school. It's very hard to wrap your finger around it. So let's say we had 10 students, 10 lockers. The first student comes in and opens every single multiple of 1, which is every single locker. Everything's a multiple of 1. The second student is going to come in and do the opposite, so close all the multiples of 2, which are obviously the evens. So they're going to So we're just making an organized list. So what happens is the first student has come in here and opened all the lockers. The second student has entered here and closed the even ones. Here's where it gets a little more complicated. Now the third student comes in and does the opposite to every multiple of 3. So 3 was opened, and now it's closed. 6 was closed, so now it's open. 9 was opened, so now it's closed. Maybe you can now understand my notation a little better, so we're going to go a little faster. 4 was closed, and now it's open. Okay. 8 was closed, and now it's open. The fifth student comes in, and they are going to close 5, and they are going to open 10. And now it gets pretty quick. Okay, from 6, 7, 8, 9, and 10, they're only going to have 1 locker to touch. Okay, so number 6 is going to close the 6th locker. Number 7 is going to close the 7th locker. Number 8 is going to close the 8th locker. Number 9 is going to open the 9th locker, and number 10 is going to close the 10th locker. So you can see, if there were 10 students in our school, locker 1, 4, and locker 9 would be open. Okay, maybe you recognize those numbers. Hopefully you recognize those numbers. But if you don't, then maybe you can look for a pattern. So that's going to be our third problem-solving technique. Look for patterns. Okay, so 1, skip 2, 4, skip 4, 9, maybe we guess that we skip 6, or you can maybe say 1 plus 3 is 4, 4 plus 5 is 9, and 9, so maybe we're going to guess plus 7. So let's test number 16. Okay, so student number 1 would open 16. Student number 2 would close 16. Student number 4 would open it. Okay? Student number 3 didn't touch 16 because they weren't, 16 is not a multiple of 3. So the next student to touch locker 16 will be 8. They're going to close 16, and then the final student to touch locker 16 will be student 16. And so indeed, 16 works. Okay, so our first open lockers are 1, 4, 9, 16. Remember, 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16. So now we know that the next one will be 25. Now by now, you guys are probably screaming, hey, those are the perfect squares, and indeed. So now we know that the open lockers will be 1, 4, 9, 16, 25, 36, 49, all the way to the final open locker, and that's the biggest perfect square. That is less than 1,000, and I believe my memory tells me that is 32. Nope, 31. That's right, all the way up to locker 31, which will be the final locker that is open. I'm sorry, 31 squared, all the way up to 961. Now, why are the perfect squares open? It's because if you look, they have an odd number of factors. Each perfect square will have a factor right there in the middle, whose partner is itself. Otherwise, 1 times 16 is 16. 2 times 8. That's the lonely factor. Its partner is itself. That makes an odd number of factors, and that's why the perfect squares will be the only lockers that remain open, because they're the only lockers with an odd amount of factors. I hope you've enjoyed your first drive-through installation. Boom!